When simplifying rational expressions, you're going to first rewrite all expressions in descending order. You're going to factor both the numerator and the denominator, and always remember to factor out the negative. You're going to reduce the expression by canceling out common factors, and then you're going to rewrite any remaining factors as a single rational expression. In number 1, this is just dividing with powers, but we're going to factor it just so you can see exactly what happens. So 27 factors into 3 times 9, and r to the 5th factors into r times r to the 4th. And on the bottom, we have 9 times r. So what happens here is you cancel out factors that are the same in the numerator and the denominator, and then you rewrite as a single expression whatever's left over. Similarly, in number 2, if we factor each of these expressions, so I have 32y plus 16, well, these both have a 16 in common, and that leaves me with 2y plus 1. On the bottom, 18y plus 9, these both have a 9 in common, and that leaves us with 2y plus 1. So you cancel out the common factor in the numerator and the denominator, and then you rewrite what's left over as a single expression. In number 3, we factor the numerator and the denominator, so I have a 12m in common, and that leaves me with m minus 5. On the bottom, we have 4m times m. So the 12 over 4 reduces to 3, and one of the m's will cancel. And I'm left with 3 times m minus 5 over m. In number 4, this is an example of when you need to make sure you factor out the negative. So in the bottom of my fraction, I have b minus a, and in the top, I have a minus b. If I factor a negative out of the bottom of the fraction, then the bottom of the fraction becomes negative times a minus b. Now I have an a minus b in both the numerator and the denominator, and that leaves me with 1 over negative 1, so just negative 1. In number 5, if we apply our powers, I have negative 27 x to the 6th times x minus 7 times x minus 7. On the bottom, I have 9x squared, and here's another factor out the negative. So I have negative x minus 7. So I cancel out the terms that are the same on the top and the bottom. My x to the 6th can be written as x squared times x to the 4th. So x squared cancels. My negative 27 over negative 9 reduces to positive 3. So I have 3x to the 4th times x minus 7. In number 6, it requires me to factor both the numerator and the denominator. So I'll start with the numerator. I'm looking for 2 factors that will multiply to give me negative 24, but add to give me negative 10. So I'm going to use 2 and 12. My larger number is always the same sign as the top, and if my bottom number is negative, that means one must be negative and one must be positive. So this is 3b squared plus 2b minus 12b minus 8. I have a b in common, and that leaves me with 3b plus 2. I have a 4 in common, and that leaves me with 3b plus 2. So the top factors into 3b plus 2 times b minus 4. On the bottom, I'm looking for two factors that multiply to give me 6 and add to give me 5. So I'll use 2 and 3. The larger number is the same sign as the number on top, and if I'm positive on the bottom, then both numbers have to have the same sign. So this is 3b squared plus 2b plus 3b plus 2. I have a b in common, and that leaves me with 3b plus 2. I have a 1 in common, and I have 3b plus 2. So the bottom factors into 3b plus 2 times b plus 1. So I have 3b plus 2 times b minus 4 over 3b plus 2 times b plus 1. I cancel out the factors that are the same on the top and the bottom, and then I'm left with what's left over. Number 7, I'm going to factor out a negative because when I rewrite this in descending order, I have a negative leading coefficient. And I don't normally work with a negative leading coefficient. And so if I factor the negative out front, then that means my signs will change. And on the bottom, this becomes 2n plus 5 times 2n minus 5. Now, if you attempt to factor what's inside the parentheses, you're looking for two numbers that multiply to give you negative 100, but add to give you positive 20. This is an example of an unfactorable quadratic, or what we call a prime polynomial. And so in this case, this is as far as you can go. We rewrote it in descending order, and we simplified it as much as we could, but we don't have any common factors to cancel out. And number 8, starting off the same way, I'm going to rewrite the numerator and the denominator in standard form. So I want it in descending order by degree. Once I have them in standard form, then I want to factor the top and the bottom. So I'm looking for two numbers that multiply to give me 12 and add to give me positive 7. So I will use 3 and 4. So this would be 6z squared plus 3z plus 4z plus 2. So this is 3z times 2z plus 1 plus 2 times 2z plus 1. So the top factors into 2z plus 1 times 3z plus 2. On the bottom, I'm looking for two numbers that multiply to give me 24 and add to give me positive 14. So I'll use 2 and 12. So this is 3z squared plus 2z plus 12z plus 8. So I have a z in common, and that's 3z plus 2. I have a 4 in common, and that leaves me with 3z plus 2. So the bottom factors into 3z plus 2 times z plus 4. I cancel out the common factors on the top and the bottom, and I'm left with what's left over. In number 9, we have a difference of perfect cubes on the top. So when we factor a difference of perfect cubes, we take the cube root of the first term, the cube root of the second term, times the cube root squared of the first term, the product of each of the cube roots, and the cube root squared of the second term. And then this is SOAP. So it's the same sign, the opposite sign, and always positive. On the bottom, when you put this into standard form and factor out your common factor, I have a times a squared plus 3a plus 9. We cancel out the things that are the same on the top and the bottom, and then you're left with what's left over. In number 10, when I factor the top, I have x cubed minus 4x squared minus 4x plus 16. So between my first two terms, I have an x squared in common, and that leaves me with x minus 4. In my second two terms, I have a negative 4 in common, and that leaves me with x minus 4. So I have x minus 4 times x squared minus 4. Now, x squared minus 4 is a difference of squares. So I need to factor one more time. And this gives me x minus 4 times x plus 2 times x minus 2 for my numerator. In my denominator, when I factor, I'm going to have x squared plus 4 times x squared minus 4. Well, again, that x squared minus 4 is a difference of squares, so it needs to be factored. So x squared minus 4 becomes x plus 2, x minus 2. You cancel out the things that are the same on the top and the bottom, and you're left with what's left over.